అందరూ మంచి నిద్రలో ఉంటారు తినేసి. Guys, good afternoon. So today we are discussing the entire physical chemistry. Okay, the important formulae of physical chemistry completely. Okay, from first year to second year completely. Okay. Alright, most of you students, both online and offline students, you had your breakfast, lunch I think. Okay. So keep listening and write the formulae on some paper. If you prepare these formulae, you can answer physical chemistry questions. Yeah, coming for that. See, we have the physical chemistry. First chapter is structure of atom. In structure of atom, what are the formulae we have? We are going to find. Okay, first one is structure of atom, which is atomic structure, also called atomic structure as well as structure of atom. Okay, structure of atom. In structure of atom, we are going to classify into different parts. The first one is radiation, means electromagnetic radiation. And besides the electromagnetic radiation, some other atomic models we have, especially Bohr's atomic model. After the Bohr's atomic model, we have different theories. Based on the theories, we are going to find somewhat formulae. The first one is electromagnetic radiation. Electromagnetic radiation. What are the formulae we have? You just recollect as the numbers. The first one is C, means velocity of the light equal to frequency into wavelength. Frequency into wavelength. The value of the C equal to 3 into 10 power 8 meter second inverse. That is the constant actually. If you need to write energy of any given radiation, that you can write E equal to h nu, you can write, where h is Planck's constant, the value is 6.625 into 10 power minus 34 joule seconds. Okay, then from this you are going to write E equal to number of photons, also you can write E equal to nh nu, so that you can write E equal to nhc by lambda, that 1 by lambda is called wave number, so you can write nhc nu bar, you can write. These are the formulas related with electromagnetic radiation. Electromagnetic radiation. Okay. Right. Right, see the next one. Second one, called photoelectric effect. Photoelectric effect. In photoelectric effect, what are the formulae we have? That is energy of the radiation equal to threshold energy plus kinetic energy of the given electron. The threshold energy is also called work function. So you can write energy equal to work function plus kinetic energy. If you need to calculate the kinetic energy of a given electron, that you can write kinetic energy equal to E minus E naught. You can write that kinetic energy equal to E is nothing but H, you can take common, mu minus mu naught. As we have already, mu is nothing but C by lambda. So you can write C Hc into, otherwise you can write Hc into 1 by lambda minus 1 by lambda naught. This is related with the photoelectric effect. Photoelectric effect. Yeah, coming for the next formulas. It's not last. Continue to this. Okay, now the next important is atomic models. That is Bohr's atomic model. Before that, we can have some other formulas. That is Millikan oil drop experiment. Millikan oil drop experiment. Oil drop experiment. That we have the formula, the charge of oil drop equal to number of electrons into charge of electron. Charge of electron. That is, the charge of electron is always minus 1.602 into 10 power minus 19 coulombs. 1.602 into 10 power minus 19 coulombs. If you need to find the charge of 1 mole of electrons, that is obviously 1 Faraday, that equal to 96,500 coulombs you can write. Okay. Right. Next one. Millikan oil drop experiment. Based on that we can find. We have actually atom of elements. That atom of elements are present in different isotopic forms. Different isotopic forms. Then if you need to find the average atomic weight of any element, then how do we write? The percentage of abundance of element, that is atomic weight A into X plus weight, different atomic weights. For example, we can have with Z1 or atomic mass, we are going to concentrate as A1 X percentage, B or A2 you can say, different atomic weights, A2 Y percentage. Then how do we write? Average atomic weight equal to, how do we write? The simple thing, XA1 plus YA2 whole by X plus Y. This is the average atomic weight of a given element or a given atom. Okay. My online students, I am going to ask you how many formulas we are collecting in each chapter. Okay. Just write the numbers also. So the next one. See the next one. Coming for the atomic models, the first one is Bohr's atomic model. In this Bohr's atomic model, how many number of formulas we have and what are those? The first one is radius of nth orbit. That is, you can write 0.529 means 0.53. This you can write n square by z angstroms. That is for radius of nth orbit for hydrogen and hydrogen-like atoms. Then coming for the energy of electron in nth orbit, total energy we are writing, that is minus 13.6 z square by n square electron volt per atom. If you need to what is that? If you need to convert the electron volts into joules, the relations 1 joule equal to, otherwise you can write directly, 1 electron volt equal to 1.602 into 10 power minus 19 joules, and 1 calorie equal to 4.18 joules. If you need to convert into 1 mole, that 1 mole equal to 6 into 10 power 23. These are interconversions. If you need to convert the energy into different forms. Okay. Then the next one, third one. The total energy and kinetic energy relation, energy equal to minus kinetic energy, or kinetic energy equal to minus total energy, minus total energy. Kinetic energy of electron equal to minus total energy of electron. Whereas potential energy, if you need to find, that is exactly half of the total energy of the electron. That is another formula. And the next one, the velocity of electron in nth orbit, that is Vn, we can write that Vn equal to, we can write 2.18 into 10 power 8 Z by n centimeter second inverse. That is velocity of electron in nth orbit. Okay. Write down. So these are the important formula of Bohr's atomic model. Here only we can find delta E equal to E2 minus E1. E2 minus E1, that you can write H nu. H nu. The angular momentum of electron, we are going to say MVR in a given orbit equal to NH by 2 pi. This is the formula. For hydrogen spectrum, if we have, for hydrogen spectrum, how do we write the formula? The hydrogen spectrum, we are going to write nu bar equal to 1 by lambda equal to RZ square into 1 by N1 square minus 1 by N2 square. Okay. If you need to find lambda directly, you can write 1 by RZ square into N1 square, N2 square, N1 square into N2 square by N2 square minus N1 square. Okay. Coming for the R value. R equal to 109,677 centimeter inverse, whereas 1 by R equal to 912 angstroms. This you can remember. This is for hydrogen spectrum. In hydrogen spectrum only we are going to find total number of lines in a spectrum equal to, you can write N2 minus N1, where N2 means higher energy orbit, N1 means lower energy orbit. Number of lines in a particular series, equal to N2 minus N1. Whereas total number of lines, if you need to calculate, total number of lines, that is formula N into N plus 1 by 2, N by 2, where small n equal to N2 minus N1. N into N plus 1 by 2, that N is nothing but N2 minus N1. These are the related formulas with what is that? Hydrogen spectrum. Hydrogen spectrum. Okay. See the next one. After Bohr's atomic model, de Broglie's dual nature of matter. De Broglie's dual nature of matter. Dual nature of matter. So how do we write the formulas based on this? That is lambda E equal to h by mv we can write. So from this only we are going to write the radius of or the circumference of a given orbit equal to 2 pi r n equal to we are going to write n lambda. 2 pi r equal to rn equal to n lambda we can write. Lambda equal to h by mv. mv is nothing but momentum. Mass into velocity is nothing but momentum. So you can write h by p also. H by p. While coming for the next one, Heisenberg uncertainty principle. Heisenberg's uncertainty principle. Uncertainty principle. So what are the formulas we are going to find here? The change in position of electron into the change in momentum of electron is must be greater than or equal to h by 4 pi we can write. So change in momentum is nothing but the mass of the particle into change in velocity greater than or equal to h by 4 pi we can write. H by 4 pi. Okay. So after this, quantum numbers. Which is x mira. Delta x means change in position. Delta p means change in momentum. Delta v means change in velocity. Okay. Next one. Quantum numbers. Based on the quantum numbers, we are going to find different characteristic properties. Quantum numbers. So first one, principal quantum number. Based on that, we are going to find a cell contains subcell. So number of subcells are, how many we have? N. Number of orbitals, how many we have in any shell? That equal to n square. Number of electrons in an orbit equal to 2n square. Okay, that is for quantum numbers. First one, principal quantum number. Whereas azimuthal quantum number, azimuthal quantum number denotes with L actually. What is that? L. Okay, if you need to find number of orbitals, the formula is 2L plus 1. L is the values for S, P, D, F, G. For S orbital you can take 0. For P orbital you can take 1. For D orbital you can take 2. For G you can take 4. Okay. In the same way, N can have the values 0. Sorry, not 0. It is actually started from 1, 2, 3, 4, so on. This is a K shell, L shell, M shell, N shell. We can write like that. K, L, M, N. Okay. The angular momentum of an orbit. Orbit angular momentum formula NH by 2 pi. Whereas orbital angular momentum, that is root over L into L plus 1 into H by 2 pi. The online students, I'm going to ask in each chapter how many formulas you collected. Right? if you at least work over these formulas, at least దీని మీదైనా ఈ ఫార్ములాస్ పైన వర్క్ చేసినా యూ కెన్ కవర్ ఆల్ ద ఫిజికల్ కెమిస్ట్రీ కాన్సెప్ట్స్. ఎందుకని అంటే బికాజ్ ద మోస్ట్ ఆఫ్ ద క్వశ్చన్స్ ఆర్ రిలేటెడ్ విత్ ప్రాబ్లమ్స్ ఓన్లీ. మొన్న మీకు ఏపీ ఎంసెట్ పేపర్లో కూడా చూసాం మనం పేపర్ డిస్కషన్ అప్పుడు. మోస్ట్ ఆఫ్ ద క్వశ్చన్స్ ఆర్ రిలేటెడ్ విత్ డైరెక్ట్ ఫార్ములాస్ రిలేషన్ తోటే మన క్వశ్చన్స్ అన్నీ ఉన్నాయి. కాబట్టి అట్లీస్ట్ నువ్వు ఈ క్వశ్చన్స్ ఈ ఫార్ములాస్ నువ్వు బై హార్ట్ చేసినా, ఇన్ కేస్ ఆఫ్ ఏమి గుర్తులేదు అనుకున్నా, యూ కెన్ ఆన్సర్ 90% ఆఫ్ ఫిజికల్ కెమిస్ట్రీ క్వశ్చన్స్. ఓన్లీ 1 or 2 questions can be related with the, maybe a chance to related with the concept, but most of the questions are related with the formula and substitution. ఫార్ములాని మనం సబ్స్టిట్యూట్ చేసిన దాంతోనే యూజ్ అవుతాయి. ఓకేనా? అందుకే చెప్తున్నా, అన్నీ నోట్ చేసుకోండి. ఓకేనా? యూ నీడ్ టు రిమెంబర్ ద టోటల్ నెంబర్ ఆఫ్ ఫార్ములా. ఒక చాప్టర్ నేను చెప్పానంటే అందులో ఇన్ని ఫార్ములాస్ నేర్చాను అనేది కూడా గుర్తుండాలి. ఎప్పుడు వైల్ ఐఎమ్ గోయింగ్ టు రైట్ ద ఎగ్జామ్, అప్పుడు మనం కరెక్ట్గా నేర్చినట్టు. అర్థమవుతుందా? రైట్. సీ ద నెక్స్ట్ వన్. కమింగ్ ఫర్ ద what is that azimuthal quantum number, then at magnetic quantum number. For magnetic quantum number, how many values we have? Magnetic quantum number, that is 2l plus 1. Any orbital you can take. For example, s can have 1, for p we can have 3, for d we can have 5, for f we can have 7. Okay. The next, spin quantum number. Spin quantum number means s can have 2 values, that is 1/2 plus. For clockwise you are going to denote with plus sign, that is upward arrow. S may be minus half, that is anti-clockwise direction. You are going to denote with downward arrow. Anti-clockwise direction. Then after completion of this, we have one more term that is called nodes. What are those? Nodes. The nodes are again 2 types. One is called spherical node or radial node. Both are same. Radial node. And the other one is angular node or nodal plane. These two are same. These two are same. For radial nodes or spherical nodes, the formula is n minus l minus 1. For radial nodal planes or angular nodes, the number of nodes equal to L. If you need to find total number of nodes, that equal to n minus L minus 1 plus L equal to n minus 1. మన ఎగ్జామ్లో అడిగాడు, మన ఎంసెట్లో అడిగింది ఏపీలో. ఓకేనా? So first chapter is over. Atomic structure is completed. How many formulas you got? Online students. Total number of formulas, how many you got from atomic structure? ఎన్ని వచ్చాయో మొత్తం ఆఫ్లైన్? టోటల్ నెంబర్ ఆఫ్ ఫార్ములాస్ 30. అరే ఈ 35 ప్లస్ మైనస్ కదా, ఐఎమ్ ఆస్కింగ్ ఎగ్జాక్ట్ నెంబర్. 31, 32. అమ్మ ఆన్లైన్ మీరా? గాయత్రి, రాధిక, చరణ్, జువా, మనదీపిక. How many you got? Right. Coming for the next concept, next chapter, states of matter. States of matter. States of matter. Coming for the states of matter, first we have gaseous laws, right? We have gaseous laws. So based on gaseous laws, what is the first one? Boyle's law. So what is the Boyle's law? V is inversely proportional to P, right? So we can write PV equal to some constant K. Charles law, how do we write? V at T temperature equal to V naught plus V naught into V naught into 1 plus T by 273. This is the V at T temperature. Okay, that means we can write volume is directly proportional to temperature. V1 by T1 equal to V2 by T2 you can write. In the same way, P1 V1 equal to P2 V2. P2 V2. K is a constant which is depending on temperature, independent on nature of the gas. Which depends on temperature, independent on the gas. Here also, if you write same V by T equal to some constant K, you can write the K is independent on temperature, depends on temperature, independent on nature of gas, independent on nature and amount of the gas, nature and amount of the gas. Next, third one, Avogadro's law. V is directly proportional to N. V1 by N1 equal to V2 by N2 we can write. Charles' second law. Charles' second law. What is that? P is directly proportional to T. So you can write P1 by T1 equal to P2 by T2. Next one. PV equal to nRT, which is called ideal gas constant. What is that? Ideal gas equation. PV equal to nRT. So where R equal to ideal gas constant, which has the value 8.314 joule, mole inverse, Kelvin inverse SI units. Otherwise you can write 8.314 into 10 power 7 erg mole inverse Kelvin inverse. This is CGS units. Okay. Otherwise you can take R value 0.0821 liter atmosphere mole inverse Kelvin inverse. You can take that one. Otherwise 2 calories approximately. 2 calorie mole inverse Kelvin inverse. Okay. The next one. Is it over? Next one. So from this you can write P1 V1 by N1 T1 equal to P2 V2 by N2 T2. Okay. This is another formula. And next you are going to write Pm equal to density into RT. Density of the gas into RT. This is another formula where M equal to molecular weight. Where M equal to molecular weight of the gas. These are the gaseous laws. The next one. Graham's law of diffusion. R equal to rate of diffusion. the distance covered by the gaseous molecule per unit time, or volume covered by the gas per unit time, or number of moles of the gas transferred per unit time. Okay, we are going to write R is inversely proportional to square root of density or inversely proportional to square root of molecular weight or inversely proportional to square root of vapor density. From all this we can write R1 by R2, two different gases if you have, then you can write N1 by N2 into T2 by T1 equal to V2 by V1 into T2 by T1 equal to N1 by N2 into T2 by T1 equal to, you can write P1 by P2 into root over M2 by M1 into T1 into T2. Otherwise you can write root over D2 by D1 equal to root over VD2 by VD1. These are all the formulas related with Graham's law of diffusion. Okay, see the next one. Dalton's law of partial pressures. Next one, Dalton's law of partial pressures. That is P total equal to sum of partial pressures, P1 plus P2 plus P3 so on. If you need to find the partial pressure, P total into mole fraction of component 1, mole fraction into component 1, partial pressure equal to. Okay, this is in vapor state. Vapor state లో అయితే ఈ ఫార్ములా యూజ్ చేస్తారు. Whereas in the liquid state లో ఉందనుకోండి అప్పుడు ఏం రాసుకోవచ్చు, PA equal to P0A XA, PA equal to P0A XA. This is in liquid state. This is, you can write Y1 as, don't write X1, you can write as Y1. Y1 means Y is mole fraction in vapor state. Now X is mole fraction in liquid state or liquid phase. Okay. After this, kinetic theory of gases. In kinetic theory of gases, what are the formulas we have? Kinetic theory of gases. For kinetic theory of gases, the formulas are PV equal to 1 by 3 mnc square. Otherwise, you can write kinetic energy of a gas equal to 2 by 3 by 2 PV you can write, that equal to 3 by 2 nRT, kinetic energy. So from this you can write kinetic energy 1 by kinetic energy 2 equal to, you can write P1 V1 by P2 V2 you can write. Otherwise N1 T1 by N2 T2 you can write. And remember, the average kinetic energy of all gases is always equal. The average kinetic energy of all gases are same. Remember, only the kinetic energy can be different by changing different gas, but average kinetic energy is always constant for all the gases and identical. Next one, van der Waals state of equation. Van der Waals state of equation. Next one, van der Waals state of equation. Van der Waals state of equation. What is van der Waals state of equation? That is P plus an square by v square into v minus nb equal to nRT. This is for real gases. For real gases or ideal gases, we are going to write Z is as compressibility factor. Z equal to formula PV by nRT. PV by nRT, which is called compressibility factor. The Z value equal to 1 for ideal gases. Z is greater than 1, that is called positive deviation. Z is less than 1 is called negative deviation. Negative deviation of gases. Okay. The next one. At different conditions, at high temperature and low pressure, all the gases are going to behave like ideal gases. So, you can take A as 0, B is also 0. So, you can write PV by RT that equal to Z equal to 1 you can write. This is the first condition. While coming for the second condition, at moderate pressure, B becomes 0, A is not equal to 0. A is not equal to 0, B becomes 0. Then if you are going to observe the condition, you are going to get Z is less than 1, that equal to PV by RT equal to RT is less than 1, negative deviation we are going to find. So means Z is less than 1 means we are going to find less than something means Z equal to 1 minus A by RTV. 1 minus A by RTV. This is at moderate pressure. The third condition, many times asked this concept, van der Waals state of equation. Every time we are going to find at least one question. So concentrate on that. So that is the reason I am explaining the conditions also. And while I am taking high pressure, under high pressure, A becomes 0, B is not equal to 0, Z must be greater than 1. That means PV by RT must be greater than 1, so that you can get Z equal to 1 plus PB by RT you can get. Z equal to 1 plus PB by RT. Students, are you clear with this? Online students? Sai Saket, Gayatri, FF33, Radhika, Irenas. Someone can respond, please. TM Charan. Next. Okay. Next one, critical constants. TC, critical temperature, 8A by 27 RB. VC, critical volume, 3B. PB, critical pressure, A by 27 B square. Z equal to critical constant under conditions, critical conditions, PC, VC by RTC, NRTC you can write. ZC for 1 mole, you are going to find 3 by 8. This is the value, ZC. Okay. Next one. Inversion temperature. Inversion temperature equal to 2 times of Boyle's temperature. Boyle's temperature equal to A by RB. Okay. Inversion temperature equal to 2A by RB. So the relation is Ti greater than Tb greater than Tc. Ti greater than Tb greater than Tc. These are the related formulas from states of matter. The next one is equilibrium. The next concept is equilibrium. Chemical equilibrium and ionic equilibrium. Chemical equilibrium and ionic equilibrium. Okay. So in chemical equilibrium and ionic equilibrium, how do we write? For example, X moles of reactants converts into the Y moles of products. Then we are going to write Kc and Kp. From here you are going to start. How do we write Kc? Kc equal to concentration of P power Y by concentration of R power X. For solids and liquids, the concentration and partial pressure can be taken as concentrations and partial pressures can be taken as 1, always unity, always 1. Kp equal to, how do we write? Partial pressure of product power Y by partial pressures of reactants power X you can write. The relation between Kp and Kc, Kp equal to Kc into RT power delta N, where delta N equal to number of moles of products minus number of moles of reactants, which must be gases. Okay. Next conditions. If Kc less than 10 power minus 3, that reaction cannot proceed. Reaction does not happen, means the reaction cannot be processed. That means you can find only reactants. This is the first condition. If Kc greater than 10 cube, that indicates reaction completed. Reaction completed. That means only products you can find. Whereas if Kc range is 10 power minus 3 to 10 cube, that indicates that is there in equilibrium condition. Both reactants and products are present in the container. Both can be obtained or both can be present in the container. Okay. Partial pressure of P power Y, because P is the product, R is the reactant. Next, coming for Kc units, moles, later inverse, power delta N. Kp units, atmosphere, power delta N. Okay. Next, Kp and Qc relation. Kp means or Kc means equilibrium constant, Qc means reaction coefficient. If Kc greater than Qc, the reaction proceeds in a forward direction. The second condition, if Kc is less than Qc, reaction proceeds in backward direction. If Kc greater than Qc, the reaction proceeds in forward direction. If Kc equal to Qc, that indicates that is present in equilibrium. That is present in equilibrium. The relation between delta G naught and Kc equal to minus 2.303 RT log Kc. The Qc and delta G relation, delta G equal to delta G naught plus 2.303 nRT log Qc. Delta G relation and Qc Kc relation. And next one, for the degree of dissociation, alpha dissociation equal to, if you have vapor densities, d minus d by small d into n minus 1, where d equal to equilibrium vapor density, capital D equal to initial vapor density. Initial vapor density. This is the first one. For the reactions like A gives rise to B plus C. Example, PCl5 is the only reactant can decompose into PCl plus 3 Cl2. PCl3 plus Cl2. In such a case, the degree of dissociation alpha equal to root over Kp by Kp plus P at equilibrium, total pressure at equilibrium. The third condition, if you have A2 by implies 2A, the same reactant converts into identical products, two molecules. In such a case, the alpha equal to formula Kp by Kp plus 4Pe. 4Pe. These are the important formulas in chemical equilibrium. Coming for the ionic equilibrium. Alpha 4 PE. PE means equilibrium pressure. PE means total equilibrium pressure. Okay. Now the next one. Ionic equilibrium. For strong acids and strong bases. For strong acids and strong bases, we are going to use like this kind of formulas. See, pH equal to minus log concentration of H plus. If you need to find concentration of H plus, that equal to 10 power minus pH. In the same way, POH equal to minus log concentration of OH minus. OH minus concentration equal to, that is 10 power minus POH. The pH plus POH for any compound equal to 14. This is exactly at 25 degrees centigrade. The concentration of H plus or concentration of OH minus, the both can be increased with increase in temperature. Both can be increased with increase in temperature. Okay. So that is the degree of dissociation of water is directly proportional to the temperature. So that what will happen? The pH of water is inversely proportional to the temperature. pH or POH, anything. pH or POH is inversely proportional to temperature. Then the next one. The degree of dissociation of water equal to absolutely 1.8 into 10 power minus 9. 10 power minus 9. Minus 9. Next. This is called ionic product of water, concentration of H plus into concentration of OH minus. This is absolutely 10 power minus 14 at 25 degrees centigrade temperature and 1 atmospheric pressure. This is for strong electrolytes. Okay. Then coming for weak acids and weak bases. For weak acids and weak bases, how do we write? Weak acids and weak bases. First one, alpha equal to root over Ka by C. The second one, H plus concentration equal to C alpha, that equal to root Ka into C. Okay. Next one. Third one. Alpha for bases is root over Kb by C. So that you are going to find concentration of OH minus equal to C alpha, that equal to root Kb into C. Kb into C. Where C is concentration. Ka means acidic strength constant. Kb means basic strength constant. Ma? Kw means ionic product of water. Ionic product of water. Ionic product of water. Next one. Ionic product of water. Next one. Salt hydrolysis. Salt hydrolysis. The salt of strong acid and strong base. The pH equal to 7 because it is neutral. The salt of strong acid with weak base means the salt is acidic, so pH is 7, means solution is acidic in nature. So if you need to find pH, you need to subtract something. 7 minus 1 by 2 pKb plus log C. Then the third one, the salt of weak acid with strong base. The pH equal to, pH is greater than 7 because the solution is basic in nature. You need to add something. So pH equal to 7 plus 1 by 2 pKa plus log C. Okay. If you need to find KH, hydrolysis constant, that equal to Kw by Ka for base acids, whereas here KH equal to Kw by Kb. Okay. Kw by Kb. If you need to find degree of hydrolysis, H, the formula is same for all the compounds, that is H equal to root over Kh by C. Kh by C. Everywhere this is the same formula. The last combination, the salt of weak acid with a weak base. The pH can be anything. Means the pH equal to 7 plus 1 by 2 pKa minus pKb, means irrespective to the concentration of solution, the pH is irrespective to the concentration of solution, means the pH is neither changed by addition of water nor changed by decreasing of volume. The pH is remains constant because depending on only pK and pKb. This is also called neutral buffer. This is also called neutral buffer solution. Okay. The next one, if you need to find KH, that you can write Kw by Ka into Kb. Ka into Kb. Students, we are giving many formulas now. The entire formulas we are giving. The only thing is, you need to learn at least by heart the formula and practice over there. You can do directly. Because the chemistry problems means the matter of substitution only. If you know the exact formula. Maths lo anukondi meer application cheyali. Physics lo anukondi application cheyali. Ade chemistry lo vachesariki em ante the only matter with the formula. If you have the correct formula, you can substitute the values there in the question. మనకి ఏది క్వశ్చన్లో ఇచ్చిన వాల్యూస్ ఉన్నాయో ఆ వాల్యూస్ని మనం సబ్స్టిట్యూట్ చేసి ఈజీగా క్యాలిక్యులేషన్ చేయొచ్చు. అండ్ వన్స్ అగైన్ అనదర్ ఇంపార్టెంట్ థింగ్, దిస్ ఈజ్ ద వెరీ వెరీ ఇంపార్టెంట్ స్కోరింగ్ సబ్జెక్ట్. జనరల్గా మంచి స్కోరింగ్ సబ్జెక్ట్ ఎవరైనా అంటే కెమిస్ట్రీని, అన్ని సబ్జెక్ట్స్లో. మ్యాథ్స్ తర్వాత రోల్ ఎవరికి ఉంటుందంటే ఎంసెట్లో కెమిస్ట్రీకి. కెమిస్ట్రీని బాగా స్కోర్ చేస్తే నీకు మంచి ర్యాంక్ ఉంటుంది. యూ కెన్ గెట్ గుడ్ ఇంజనీరింగ్ కాలేజ్. ఓకేనా? రైట్. నెక్స్ట్ వన్, buffer solutions. As we did already, neutral buffer. So coming for the acidic buffer. Acidic buffer pH formula. pH equal to pKa plus log concentration of conjugate base by concentration of weak acid. Because acidic buffer means the combination of weak acid with salt of weak acid with a strong base. Whereas basic buffer BB, we are going to find pOH. The formula pKb plus log concentration of conjugate acid by concentration of weak base. Weak base. If you need to find buffer capacity, that is going to denote with pi, that is you can write delta pH by n into volume in liters. Buffer capacity. Pi is called buffer capacity. Next, solubility and solubility product. Okay. So KSP, how do we write? Concentrations of cations and concentrations of anions. AB type means one cation and one anion. KSP equal to what is the formula? Solubility square. AB 2 type salts. 2 anions and 1 cation, or 2 cations and 1 anion. The KSP formula 4s cube. 4s cube. The third one AB3 type, KSP equal to 27 s power 4. The fourth one A2B3 type, we are going to write KSP equal to 108 s power 5. The relation between QSP and KSP. If QSP greater than or QSP less than KSP, such solution is unsaturated solution. That means we are not going to get any precipitation. No PPT. If QSP is equal to KSP, such solution is called saturated solution. In this case also you are not going to find any precipitation. No PPT. Whereas QSP is greater than KSP, then you can find a super saturated solution. In this case you can find precipitation. Those are the conditions to get precipitate by giving solubility relation. As we discussed yesterday, question paper lo kuda discuss chesindi, solubility product is directly proportional to solubility of a given substance in water. Okay. So this is chemical equilibrium and ionic equilibrium. The next concept is thermodynamics. Thermodynamics. So first we are going to start it from W. Work equal to, what is the formula? Plus or minus P delta V, right? This is for irreversible, okay? Otherwise you can write plus or minus delta N RT. Otherwise we are going to write plus or minus P delta T, because delta V is directly proportional to delta T. Work can be taken positive when work done on the system. On the system means gas expansion or compression. Volume decreasing means gas compression. The work can be taken as negative sign. Work done by the system. The gas expansion is observed means volume increases. Volume increases. Right. The next one. Internal energy formula 3 by 2 nRT. Enthalpy formula 5 by 2 nRT. Okay. From thermodynamics first law we can write delta U equal to plus or minus Q plus or minus W. Okay. So now plus Q when the system absorbs heat energy, minus Q when the system releases heat energy. Heat. Okay. Next, relation between delta H and delta U. Delta H equal to delta U plus delta nRT. This is fourth one. While coming for the fifth one, delta H equal to delta U plus delta nRT. Okay. The next one after this, delta U equal to CV into dt. The same way, delta H equal to Cp into dt. Cv means molar heat capacity at a constant volume. Cp means molar heat capacity at a constant pressure. The relation between Cp and Cp, Cp minus Cv equal to R. Cp minus Cv equal to R. Completed? Right. See the next one. Coming for the delta S. Delta S means Q reversible by dt. Q reversible by dt. In the same way, if you need to write work reversible formula, what is the formula? Minus plus or minus 2.303 nRT log V2 by V1. Plus you can take for by the system, on the system, minus you can take by the system. In the same way, otherwise you are going to write plus or minus 2.303 nRT log P1 by P2. In the same way, delta S reversible, if you need to find the similar formula, you are going to find, what is that? Plus or minus, you can take generally for system, it is losing minus 2.303 nR, don't use T, you can write log V2 by V1. This is for isothermal process, means temperature constant. Isothermal process. There is no T. దీనికి difference చూసుకోండి. Here we are going to find temperature, but here no temperature term. In this case, there is no temperature term. The next one, change in Gibbs free energy. Delta G equal to delta H minus T delta S. If delta G is 0, that is equilibrium. If delta G less than 0, that is spontaneous, can be occurred. If delta G greater than 0, which is non-spontaneous. Non-spontaneous. This is for thermodynamics. Stoichiometry means that is complete related information in among all the chapters. Any chapters lo kuda stoichiometry related concept. Danikondi special game formulas em నేర్చుకోవాల్సిన అవసరం లే. Repeated formulas, number of moles equal to given weight by molecular weight. Number of gram equivalents equal to given weight by gram equivalent weight. Molarity, normality, everything will come. So related to the solutions. Kabatti solutions lone direct cheppedam. Okay na? Is it over? Next one, solutions. Second year kochara. First year complete the physical chemistry is over. We're coming for the second year. Solutions. First concentration methods. Weight fraction equal to formula. What is the formula? Weight fraction. Weight fraction. Weight of solute by weight of solute plus solvent into 100. You can take in grams. Volume fraction equal to volume of solute by volume of solute plus volume of solvent into 100. Small v indicates solute, capital V indicates solvent. Okay. Next one, weight by volume percentage equal to weight of solute by volume of solution in milliliters into 100. The next one, ppm, parts per million, equal to number of parts of solute by total number of moles of solution into 10 power 6. 10 power 6. The 10 represents number of parts of solute by total number of parts of solution into 10 power 6. Next, molarity, number of moles of solute by volume of solution in liters. The number of moles equal to given weight of solute by molecular weight of solute into 1000 by V in milliliters, volume of solution, where A equal to solvent, consider B equal to solute. You can consider like this. Next, normality equal to number of gram equivalents of solute by volume of solution in liters. That you can write WB by MB into 1000 by V in milliliters into N factor. The relation between normality and molarity. Normality equal to molarity into N factor. Eighth one. Weight of solute by molecular weight of solute into 1000 by weight of solvent. Ninth one. Mole fraction equal to number of moles of one component by total number of moles of all components. Among all these methods, this one, 8th one and 9th one, these two are temperature independent. Remaining all are temperature dependent. Temperature independent methods are only two we have. One is molality and the other one is mole fraction. Temperature independent. Okay. Rasera? Next one. Relative lowering of vapor pressure. Delta P by P naught equal to mole fraction of solute. Second one. Delta P means P naught minus P. P naught minus P. For ideal solution, we can write P total equal to P naught A XA plus P naught B XB. This is formula. The boiling point C. Boiling point delta TB, delta TF freezing elevation, boiling point, depression in freezing point, RLVP relative lowering of vapor pressure and vapor pressure. Lowering of vapor pressure. You can remember like this. You can remember RLVP means delta P by P naught. 1, 2, 3, 4, 5 delta P. Even sixth one, that is osmotic pressure. These all are directly proportional to concentration of solutions, except delta TF. But TF is inversely proportional to concentration of solution. This is change. Remaining all are directly proportional to concentration of solution. So coming for the delta TB, how do we write? Delta TB equal to Kb into vander factor into molality, small m. Delta TF equal to I into Kf into molality. The eighth one, osmotic pressure equal to I into concentration into RT, temperature. If you need to find I value for alpha dissociation equal to I minus 1 by N minus 1 into 100 for percentage. Otherwise for dissociation I minus 1 by N minus 1. Okay. Alpha dissociation means dissociation percentage. If you need to find alpha association, the formula is 1 minus I by 1 minus 1 by N. 1 minus I by 1 minus 1 by N. That is for dissociation. and association formulas. This is solutions. And only 2 chapters we have: chemical kinetics and electrochemistry. Chemical kinetics and electrochemistry. Last one only freezing point of solution is inversely proportional to concentration, directly, because that is colligative property. Colligative property is always directly proportional to concentration of solution, because colligative properties depends on the number of solute particles. Okay. Next one, chemical kinetics. Next one, chemical kinetics. How many formulas we have? Rate of reaction equal to change in concentration of reactants or products per unit time. Rate of reaction is nothing but change in concentration of reactants per unit time. Okay, this is 2 types, right? Rate instantaneous, how do we write? Minus dx by dt we can write. Average we are going to write delta C by T, delta C by delta T. Next, if you have any equation ఎలా ఇచ్చాడు అనుకోండి, N2 plus 3H2 gives rise to 2NH3. How do we write? ఏ రాసుకోవచ్చు చెప్పండి? Minus D concentration of N2 by dt means disappearance of concentration of nitrogen equal to minus 1 by 3 D concentration of hydrogen by dt means rate of disappearance of hydrogen equal to plus 1 by 2 concentration of D concentration of ammonia by dt we can write. This is rate of disappearance of nitrogen equal to 1 by 3 rate of disappearance of hydrogen equal to 1 by 2 rate of appearance of ammonia. If you know the relation, so that you are going to get the solutions. That is another model. And after this, we are going to write rate expression. So rate is going to depends on rate constant K. K equal to, we are going to write A into exponential of minus EA by RT. If you are going to apply ln K equal to ln A minus EA by RT. At 2 different temperatures, how can we write? Ln K2 by K1 equal to minus 2.30. Otherwise you can write EA by R. EA by R into T2 minus T1 by T1 into T2. T1 into T2. The expression, for example, X moles of A converts into products. How do we write? R equal to K into concentration of A power X you can write. K is rate constant, R equal to rate of reaction, A is concentration of reactant power X. Okay. right? Next one. Okay, na? Next, based on order of the reaction. For zero order reaction, what is the formula? Zero order reaction. T of is directly proportional to initial concentration of reactant power n minus 1 you can write. 1 minus n. This is T of relation. Okay na? For zero order reaction, K equal to A naught minus A by T. Rate constant equal to. Rate constant K units equal to R units. రెండు ఈక్వల్ అవుతాయి ఎందుకంటే రేట్ కాన్స్టెంట్ ఈక్వల్ టు మోల్స్ లేటర్ ఇన్వర్స్ పవర్ n minus 1 or 1 minus n. Power 1 minus n time inverse. This is the rate constant units. Okay. As n equal to 0, rate constant units and rate units both are same. Next, if you need to write T of equal to A naught by 2K you can write for zero order reaction. The next, first order reaction. First order reaction. Same formula. K equal to 2.303 by T into log A by A minus X. Formula. Coming for the K units just time inverse. K units just time inverse. Whereas if you need to find T of equal to, you can write 0.693 by K. Independent on concentrations. Independent on concentrations. If you need to write Tx by Ty, the formula is log 100 by 100 minus x by log 100 by 100 minus y. Tx by Ty equal to. This is a chemical equilibrium, chemical kinetics. The last one, electrochemistry. 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 Electrochemistry lo cheppana. First one, from Ohm's law. How do we write? V equal to IR. R equal to rho into L by A. R equal to rho into L by A. Next, R equal to rho into L by A. The next concept, R equal to rho into L by A. K means specific conductance equal to G into G star. What is G? G equal to 1 by R. G star equal to cell constant L by A. Okay na? Next one, lambda m equal to molar conductance. What is the formula? 1000 K by m. Simon centimeter square mole inverse. In case of SI units, the formula K by 1000 m Simon meter square mole inverse. The lambda m molar conductance. If you need to find equivalent conductance, what is the formula? Lambda Eq equal to 1000 K by normality. The units are Simon centimeter square gram equivalent inverse. This is CGS units. If you need to write in SI units, that is K by 1000 N Simon meter square gram equivalent inverse. This is SI units. Lambda Eq. The relation between lambda Eq and lambda N, that is lambda M equal to N factor into lambda Eq. The relation. Next, Faraday's laws. From Faraday's laws, what is the formula? First law, W equal to EIT by F. EIT, equivalent rate, electrochemical equivalent. Electrochemical equivalent. EIT, that equal to, you can write E into Q. Q means charge. Otherwise, you can write W equal to EIT by NF. EIT by F. You can write MIT by NF. MIT by NF. Where M equal to molar mass, N equal to N factor, F equal to Faraday, I equal to current in amperes, T equal to time in seconds. For second law, you can write W1 by E1 equal to W2 by E2. This is second law. This is first law. Okay. Next one. After Faraday's laws, nearest equation we have. Antana? చూడండి. Galvanic cells. Galvanic cell రాసేటప్పుడు ఏం రాస్తాం? EMF, E naught cell equal to E naught cathode minus E naught anode. When we have SRP, standard reduction potentials unde. If you have SOP, quite reverse. E naught anode minus E naught cathode. Next, delta G equal to minus NF E cell, or delta G naught equal to minus NF E naught cell. What is the nearest equation? E cell equal to E naught cell minus 0.059 by N into log QC. The Kc and E cell relation. E naught cell equal to 0.059 by N into log Kc. The pH relation. E cell equal to minus 0.059 pH. These are the different equations. So this is the end of the formulas related with all physical chemistry. If you refer them, you can answer 90% of the questions from your final exam paper. Okay guys, wish you all the best. No? Thank you. Online students, for you also, wish you all the best. I hope you can prepare all the formulas which we gave. Wish you all the best. Bye, Amma.